datum is a very important concept in geometric geodesy. It's a surface that the computations are done at it. For example, when we do the horizontal computation in surveying, we assume that the Earth is a plane. So we can use the definition of line at the surface of a plane, or the planar form. Well, but the physical shape of the Earth as we define, which is geoid, is complicated, and we cannot use it for the horizontal coordinate calculations. Therefore, we select a biaxial ellipsoid, that which has the best fit to the mean sea level, and fit it to the geoid in a global sense. In that case, this ellipsoid is called the global datum. Global datum, because the fitting of the ellipsoid is done based on all points over the geoid, all over the Earth. But if our target is just to fit this ellipsoid to a small area or some specific area, and it's not important for us how large are the discrepancies on the other side of the Earth or the other side of the geoid, then we call this datum local datum. This fitting is done based on least squares principle. Least squares says that the residuals, the square of residuals, or summation of a square of residual should be minimized. So geoid can be a residual because it's, if they consider that the ellipsoid is an average value for the geoid, then differences between the geoid and ellipsoid is considered, it will be residuals, and we will square them and take the summation, and we determine the ellipsoid parameters in such a way that this integral or the summation of the squared values are minimized, which is actually the principle of least squares fitting. We can also do the same fitting based on the deflections of vertical. So based on the definition of the datum, now we can see the differences between the geodesy and surveying. In these two subjects, we have three domains: measurement domains, coordinate domains, and domain of maps. So we measure something, we do some computations for coordinates, we come to the coordinates, and based on some computations, we transfer the coordinates to the maps. The main point is that in surveying, which is based on Euclidean geometry, the datum that the measurements are done in at that is planar or planar surface. The computations are done based on the geometry of the surface as plane geometry. The coordinates are computed and when they want to be transferred to the maps. Maps also are in two-dimensional, and they have planar geometry. And if we want to, for example, do the inverse problem, and we have some plan to set out some structure or some border or for parcels or whatever, we have the maps. We can extract the coordinates from the maps and come back to the coordinate domain suitable for transferring to the measurement of the surface. So this is called setting out or inverse problem, and a direct problem from the measurement to coordinate to the maps, or from the maps to the measurement, which is first problem. So as you see, in surveying, the geometry between these three domains is the same. It's the same. It means that we have planar geometry. But in geodesy, when the size of the area is bigger, larger, you cannot ignore the curvature of the Earth. Even if you do measurements based on the planar geometry, for example, measuring distance, measuring angles, heights, whatever. For computations, preparing them to the coordinate, you have to do some changes or compute how much these measurements will be at the surface of the ellipsoid. Then when you did that transfer, then you have to compute the coordinate based on the ellipsoidal geometry. And maps are two-dimensional. Then you need map projections to open an ellipsoid or coordinates or ellipsoidal coordinate to two-dimensional maps. Then you need map projections because it's not possible to open a sphere or ellipsoid directly to a map without accepting some distortion. The indirect problem is the same. You have these maps under the projection. You need to extract the coordinates from the map and do the inverse computation to come back to the coordinates and the domain. Also, you did the corrections or reductions of the measurement. And now you have to do these things, the opposite one, come to the measurement in the planar geometry so that you can go and set them out by instruments. So the main difference between geodesy and surveying is related to the datum, which is, of course, you can argue about the area. The area is larger, so geodesy is more pronounced there than surveying. But in a sense, the main difference is related to the geometry which is used for doing computations or all computations, say horizontal or vertical.